Welcome to this, hopefully, beginner-friendly tutorial on simulation nodes in Blender, and I'm just going to do a little demo here of some particles sort of exploding out, a bit like a firework. It's a little bit abstract, but it'll give you a good introduction to the basic concepts of simulation nodes, even if you've never really used geometry nodes before. So hopefully this will be intuitive for you. So I wanted to quickly just show you this file I made where I've done a similar sort of thing with moving particles, but I haven't used simulation nodes for this example because there was really no need to, given the simplicity of what I was trying to create. So the point is that you don't always need to use simulation nodes. You could sometimes just use, say, a noise texture that is animated instead to get some results. However, this method can be quite limited in that you will never be able to do anything given like initial velocity or anything like that. The particles will never be affected by one another, you won't be able to do collisions, and you won't be able to do any sort of convincing gravity really. So this method definitely has its limitations and it's quite niche in what you can use it for, but occasionally when you just want something simple, it can be easier to do something like this. So now I'm going to take a look at my preferred method for particle explosions in Blender, and this is just going to be using simulation nodes. So I'm just going to set up something really quick here. I think I'm going to replace this cube with a icosphere just to distribute my points on. Then I'm going to go into geometry nodes. I'm going to distribute our sort of initial points on this sphere. So you can think of this as our starting point for our simulation. And then if I had a simulation zone, connect the points in, we can now effectively add forces to these points inside the simulation zone. And the way I like to think about forces in Blender is just in terms of this set position node. So now if I add any little offset to this set position node, the particles will move by that at a constant rate. So every frame they just move down by 0.1. Now the question just becomes, how do we get the forces we want? And the first force I'm going to look at is gravity because it's the easiest. So I'm just going to call this gravity. And well, you might think this is gravity, but it actually isn't because gravity is an acceleration, not a constant velocity. So how do we make an acceleration here? We need to basically increase this value every frame by some amount. So to do that, we need to store this value as an attribute. In simulation nodes, you see on the input and the output nodes, you can add in extra values here that you can pass through. So you can sort of think of this as whatever value. So if I just connect this to the offset, you can think whatever value comes in here will then be passed through here at the next frame, and then this value is just the initial value for that. So I'll start this off at an initial value of maybe minus 0.1. And now if I play this through, you can see for the first frame it will move down by 0.1, but then after one iteration it will get set to 0 and then nothing will happen. So if I just plug this back into the offset here, just add a reroute there, you can see that now we have exactly the same as what we had before. So it's just passing this value of minus 0.1 into the offset and then passing it through back into this socket after every frame. So what do we want to do? We want to add in a vector math node in between here, and then we want to subtract a small number from this every frame. And this will be sort of our acceleration factor. So every frame, the value of minus 0.1 will get slightly bigger and bigger and bigger, and this means it will fall further every frame. So you can see that that is now what happens. And then this value here just becomes our acceleration. Now we could control this a bit easier rather than having to type in small values by adding a scale node and then maybe increasing the acceleration. That's obviously way too much, but maybe something like 1.2 is a bit better. I think 1.1 could be cool. But, you know, given that this is just a vector, you could just as easily add some component in the x direction. And you see it sort of blows like it's in the wind and it accelerates off. So that's pretty cool for some basic gravity. And you could even group this up if you wanted to, but there's no real need. Now let's look at adding in another force. And I want this force to be an explosion force, I think. So some sort of initial velocity that will push these points out from the sphere. So I'm going to just call this explosion. Now, if we go back to before we started with the simulation nodes, we started with this icosphere, which has faces, which have normals that all point out perpendicular to these faces. And it turns out this is exactly the value we want to drive our explosion force. We just want to give them velocity that is equal to the normal velocity, or parallel to it. So to do that, after we distribute our points here, you see we get this really nice normal value. We can just plug that in as a new input, and now we get our normal force. We can plug that through to the end node here, and let's just plug it into the offset as well. And then let's just see what we get. Make sure you view the end of your node tree here, and let's have a look. So you can see it's a bit like a firework where you get the points pushed out and then they fall. Another thing you can do with the gravity force here is actually plug in a random value, and this way each particle gets a little bit of a different gravity force applied to it, so it sort of simulates some being heavier than others. So you can see here I've got a random value from 1 to 10, and that just means that some particles will get a force 10 times bigger than others. And then I've scaled this down to fit our range that we are working with of 0.01, and you can see we get a little bit more variation. And what's nice is now that we have gravity and this explosion force, they both layer on top of each other in a very natural way. And this is something that'd be really hard to achieve without simulation nodes and just trying to cheat it, you know? It's quite difficult to do this. So, you know, this is pretty nice, but how do we want to customize this? We might want to add in another scale node here. And this could be sort of our slowdown factor or our dampening. So you can see if I decrease this to 0.9, the particles don't go out as far. If I decrease this to something even much lower, you can see they barely make it out at all. So there's a lot more deceleration on this explosion force. We could also change the initial value of the explosion force by adding the scale node here before it goes into the input. And let's take a look at what that does. You can see we get the same sort of deceleration, but they just don't go as far. So if I disconnect that, you see they just go further. So it can be really useful to, you know, play with these scale nodes and find some values that you like. I think I'll set this one to 0.9 and maybe a 0.8 here or something. Now that I've tweaked the system to my liking, I am going to add in an instance on points node at the end of the simulation zone. Outside the simulation zone though, and right now I can just pick some instances that I want to have on these points. You could bring in an object from your scene here. I'm just going to use an icosphere, and I'll give it 2 subdivisions and set the radius to be something really small. And then, you know, you can do all the usual stuff with your instances with the random scale and rotation stuff. I'll just do a random scale here because you won't be able to tell that they're rotating. And I'll just give these a material, add one to the scene here. I'll just make this an emissive color, and I just want to go into the shader editor for this, and I'm just going to literally use a object info node, use the random output through a color ramp, and just set some colors that I want to use, probably something orange, and then set this to constant. Do like a blue. So go into rendered mode. I'm going to render these in Eevee with a bit of bloom on. One last thing before I go, I want to show you how you can change the start time of this simulation, because it will just start at frame 0 or the first frame of your scene here. So what I want to do is adding a little function that controls whether we turn on this skip or not, and if we turn on the skip, we basically won't use the simulation here and nothing will happen. So I want to use the scene time node. I'll check frame and I'll compare it to see if it's less than what we want our start frame to be. So say I want this to start at frame 30, just plug that in here, turn that into the skip parameter, and now it starts at frame 30. And I can add that into the group input here and call it start frame. And I can set that to an integer, set the minimum to 0. But now you can see you might have a problem if your particles are still visible before the start frame in their initial position. So what you might want to do as well is just add a switch node here and plug the same operator in, and this will just switch between our points and nothing. So now if this is before the start frame, we'll switch to using no points. And you can see our simulation starts at frame 30. Then, to render this, you may want to bake this down using the bake operator, set it to animation, bake, and there you have it. I also decided to add a bit of randomness to my initial normal velocity here, just to make it a bit more interesting in terms of the shapes that we get. So all I did here was just add in a add node with a random value from -1 to 1. You could also offset this a bit so that it sort of shoots up towards the positive direction. It favors it more than the negative direction, which can be kind of cool. To control the level of randomness, you can add a scale node after your random value and turn this down to something smaller for a more subtle effect. So I really hope this was useful to you, and I hope this gave you a nice, easy introduction to simulation nodes in 4.1.